Alright, stats class, in this video we're going to look at how to find these normal probabilities, and in this one I'm going to use Desmos for the calculations. So anytime that we see a shaded region that we're having to find, an area we're having to find, the Desmos command to do that is a normaldist command. And if you just start to open a parentheses, you'll see it says mean 0, standard deviation 1. And anytime you see z's down here identifying the values, that means you're in the right distribution. The z distribution has a mean of 0, it has a standard deviation of 1. So you can either click that or you can just click this box to start finding probabilities. By default, it goes to the standard normal. Alright, min and max, I think of that as where does the shading start, where does it end? So this shading starts at this number, negative 0.97, and it doesn't give a right number, it doesn't give an upper number. So there's my probability. Alright, and this rounds to 0.834. 0, so there is my probability. Here's another one that has an area shaded, so we need to find the area between these two numbers. This time they do give us a lower and an upper. So for the lower I'm going to put the negative 0.85 and the uppers 1.23. So there's my number, and again to 4 places that's going to be 0.6930. Now the other type of problem that you'll see here is what we call the inverse procedure, and that is when they give us an area and we have to find the z-score that has that area either to the left of it or to the right of it. So the easier one is going to be when it's to the left. And the reason that's easier is because that's the standard procedure, that is to give you the area to the left. So what I need to do in this one is I need to use something called the inversecdf. Open the parentheses, and then I just always just copy the normal distribution thing and paste it in there, but you can also just type it all out. And then you this time you do need to put the 0 and the 1 in there, and then after that you have to put another comma, and now you have to tell it an area specifically to the left. And so this area to the left is 0.2005, so I type that in there and it gives me the number that has that area to the left. Now they have these pictures of the bell curve, you can zoom in on that to look at it. So what this is saying is if I replace the upper number in this other bell curve, the normal DIST bell curve, and take this lower number away, the area to the left of this number will be that 2005 number, 0.2005. So that is a visual. You can kind of see that it matches up, and that's a little way you can check it. But the normal DIST will find areas. Inverse will find the missing numbers on the number line. Right? What if they give you area to the right? Well, you have to find area to the left. And the area to the left is always 1 minus the area to the right. So what I can do here is, in this second position, I can just do 1 minus, and then type in the number that they give me that's to the right. Right? You could also do that on a separate line and then put it in there, but there's the value, negative 0.59. Right, there's just showing you that it works. All right, then at the very end of this homework set, you're going to see these percentiles. So on this problem, I have a 92nd percentile. What a percentile means is 92% is to the left of the number that I'm looking for. So that's almost everything is below it. And so if you look at these pictures, none of them have almost everything is below it except for this one. So that's going to be our 92nd percentile visual. And then to find it, again, I'm given an area. 92% is an area. Percents and probabilities are areas in this section. And I need to find the number that has that area to the left. So that is the inverse procedure. So there's the number I'm looking for, 1.41 roughly. All right, and that's how we can use Desmos to find normal probabilities and values from normal distributions.